fine, I'm Natasha and welcome back. So today we're gonna, continue our chapter 1, and that is sets. So in our today's video, we're gonna discuss about a little bit more about intervals. So intervals. So we discuss about open intervals, closed intervals, and half closed intervals, and all those things. So etc. Yeah. So one thing is that there's a little, I want to tell you something, else in that interval topic. So it is that the set. Oh wait, let me just tell you one thing before moving on to these points. So that is in the open interval, like we had A and B. Okay, open intervals. So I told you that these brackets, these brackets are gonna be exclude. Yes, of course they're gonna be exclude, but one thing is that all the points between A and B belongs to the open interval A and B we have, but A comma B themselves do not belong to this interval. Got it? So I'm just trying to say that all the points between A and B will belong to this open interval, but A and B themselves do not belong to this interval. Okay, so let's now move on into our these points. So these are some points, like we have the set of 0 and infinity. So this is the symbol of infinity. So we usually use this symbol for to describe that something is infinity or whatever. Okay, so the set, we have a half closed interval, and you can see that this is a half closed interval. So we have two I can say two elements. Okay, let's say elements. So we have two things, as 0 and infinity. So it's saying the set 0 infinity defines the set of non-negative real numbers. What does that mean? This simply just means that this set defines the set of non-negative real numbers. Means non-negative are going to be, those real numbers which aren't going to be negative. Like, of course, then they're going to be positive. From 0 to infinity, they're gonna be positive. Okay, no negative. Okay, so the second one we have is the set negative infinity comma 0 defines the set of negative real numbers. So in this we have an open interval, and it defines the set of negative real numbers. So this means that negative infinity, this means that we have an integers. So in integers we have -1, -2, and -3, and so on. So this just simply means that the negative we'll have is good. Infinity will go to infinity. But one thing is that it's going to be negative. Okay. So from I can say that. Oh, okay. For now I'm going to say -1, 1,000. Okay, and so on. And then -1, and then it's going to be 0. That's it. No other elements. Okay. Yeah. Actually, this is it will continue. Okay. It's not gonna end. So it's just for showing you. I thought that I should write 1,000, but you already know that this will never end. So this open interval negative infinity and 0 defines the set of negative real numbers, in which the positive real numbers are not going to be in it. Okay, so the third point we have is the set negative infinity to positive infinity describes the set of real numbers in relation to a line extending from negative infinity to positive infinity. Okay, so what does that mean? So it's real simple. We have an open interval again, and in this open interval we have, from negative infinity to positive infinity. So this means that, the number will start from negative, okay? It can be like -1, 0, 0, 0, 0, 0, 0, and oh, it's really, So it's really long. So this means that it describes the set of real numbers in relation to a line that will extend from negative infinity to positive infinity. Got it? You know, the whole number line we have is from negative to positive. So that's what it means. So simply describe the set of real numbers in relation to a line extending from negative infinity to positive infinity. That's it. And let's move on to our next topic. So that's all I think in intervals, and so let me just rub the board, or maybe, okay, I'll rub the board. Okay, then we'll continue. So I've rubbed the board, and you know, so we have seen that, we know that the interval contains infinitely many points, isn't it? So let's take an example, you know, based on intervals topic. So for example, I'm going to take an easy example so that you can understand it clearly. Okay, so we have a set R, okay, we have set R. So, you know, it has X such that X belongs to a real number, comma, X, we have two numbers, -5 is smaller than X, and X is smaller or equal to 7, positive 7. You know? Have a look. Okay? Let's continue. Yeah, so I'm just going to say that we will have some, you know, these type of questions in intervals. So what we have to do is like, this is written in a set builder form, isn't it? So we have to write it in intervals, okay, in interval form. So what are we going to do is we'll just, you know, see this part, okay, this part. So we have X, okay, X, we have X. So, and, so as you can see that, you know, I've already told you about these things. You know, if we have any smaller or equal or greater or equal, then we'll say that this is absolutely going to be a closed interval. So one thing we got is that this is an half closed interval, and the smaller or greater, this simply means an open interval. Open interval, got it? Okay, so what does that mean? This means that in the beginning we will have you know, a normal bracket. It's -5, and then comma, the other number we have is 7, and in the end we're going to use the closed interval. So, you know, this big bracket. Clear? It's totally clear. Okay, so the numbers which we have between you know, which we have you know, for X, we're gonna just write those numbers in the intervals. Okay, so one thing is that this is in half closed interval, as you can see. Okay, so what if you know, what if in the question it's given to us that it is in interval form, and we have to, you know, write it in set builder form. Like, for example, you know, I'll say that, okay, we have like this form, okay, I'll say -3 and +5, okay. Okay, so what does that mean? This is really simple. So we have is that, let's take X such that X belongs to the real number. Because it's, of course, you know, we can see in real numbers we have like all natural numbers, whole numbers, integers, and everything, you know, almost everything. So in -3, let's say this is an integer because it's not going to be natural number. So integer and a number. And an integer, this is also an integer. So we have, you know, this, let's just not think about it because, you know, the integers and natural numbers comes in real numbers. So, you know, this isn't the main thing that I'm going to tell you. So this is -3 and -5. Sorry, +5. Yeah, so -3. So first we're going to write is going to be the -3. -3 is, so as you can see in the beginning we have, you know, big bracket. So this means that it's going to be smaller or equal, okay? So as you can see in this one, so we have -3 smaller or equal to X, and X will be, and in the end we have an open interval. So this means that's going to be smaller, isn't it? So you know, -3 smaller or equal to X, and X is smaller to 5. Okay, and that's it. So what if we have to find the numbers, what if we have to find the points between them? Like in -5 to 7, we can have these numbers like, okay, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4. Oh, it's saying that it's going to be actually smaller than, -5 is going to be smaller than x. Okay, so this means that x is greater than -5, isn't it? And x is smaller or equal to 7. So first we will have on the right side, we'll have 2 exact 7. But on the left hand side, so like it's saying that -5 is smaller than x. So which means that if something is like less than 10. So it's saying it's less than -5. Sorry, yeah, -5 is less than x. So this means that we're not gonna actually, that's gonna be, an old way, such way. Let's just not think about it. So it's gonna be something, any other thing. But let's not so much focus on it. Okay. So the next one we have is -3 and 5. Okay, -3. So -3 is smaller or equal to. Okay, so I can say that -3, -2, -1. 0, 1, 2, 3, and 4. Because it's saying that x is smaller than 5. So which means that we'll have 1, 2, 3, 4, 5, 6, 7, 8. 8 elements in our set R. Isn't it? Okay, so this is like all the way. So, yeah. So let's so our next topic. Our next topic is gonna be about another type of set, which is power set. So have you ever heard about the power set? In earlier classes or what? No, not yet. Oh, okay. Let's just discuss it together. Okay, so the new heading we'll have is gonna be the power set. Power set, got it? So power set is gonna be like really easy. So yeah, I have to tell you one more thing. In our intervals topic. So I would like to rub the power set topic for now. And now I'm just gonna tell you the thing about intervals. Okay, so if the number b minus a, have a look. The number b minus a is is called the length of any of the intervals. Any of the intervals. If we have like b minus a in an open interval form, so this means that it's called the length of any interval. Okay, so we can say that it's gonna be half closed interval and open interval and closed interval. It's gonna be the length of any of the intervals, like all the 4 we have, like a comma b in open interval, and then we'll have a closed interval ab. Then half closed interval, which is going to be A, and in the end, open interval. So we have a lot of, and the last one we'll have is going to be this one. Okay, so number, if we have an open interval b minus a. So it's simply just saying the number b minus a is called the length of any of the intervals. It can be an open interval, it can be a half closed interval, it can be an closed interval. Okay, so any, all the 4 ones we have. Okay, so let me rub the board and then we're going to continue on to the topic. It's going to be power set. Okay. Okay, so our next topic is going to be power set, as I've already told you. Power set. So power set is actually, let's take a set A. So all the things, all those elements we're going to have in the set A is going to be the power set. So power set simply means that, the collection of all the collection of all subsets of set A. We have taken set A. So the collection of subsets of the collection of all all the subsets that we'll have possibly in set A is gonna be the part set, the collection of those subsets. Okay, so like I told you, the set A. Okay, set A. So this is gonna be the part set. So the small definition which I'm gonna write is gonna be really simple and small one. The collection of all subsets. Yeah. The collection of all subsets. The collections of all subsets of set A are called part set. This, Okay, so the collection of all subsets of set A will be the part set. That's a really simple definition. Or you can even use it's called part subset. Okay, whatever you want to use. So, I've just written for now. I've just written the small line. So let's take example. Okay, an easy example, and the collection of all subsets of set A is called the part set. Got it? Okay, so let's take example. So for example, I'll take an easy example. So if set A, no need to write set, but I'm still writing it. So if set A is equal to the elements 1 and 2, so we have to find the part set of A. So how do we represent, part set? So we just have we have set A. So I'm going to say that it's going to be the P of A. Part set of A. Part set of A. The set which we have. Okay, so it's going to be P of A. So we have to find the P of A, all the possible, subsets of the set. So we have 1 and 2, the elements. So what could be the P of A? So we have to find P of A. So P of A is gonna be, as I told you, that phi is a subset of every set. So don't forget to write phi, because this is the main, because we'll have the main one. Okay, so phi, and the second one is gonna be the singleton set. So singleton set is gonna be 1, then 2. And then one more we'll have is, as I told you, that every set is a subset of itself. So I'm going to write the same exact 1 and 2. That's it. So we have 1 and 2 and 3 and 4. Okay, 4 elements. Okay? Oh yeah, I can say 1, 2, 3, 4. Yeah, it's 4. So, the singleton sets, first of all, the singleton sets, and then the subset of itself, and 5. These are the mainly common. And, what if we have more than 2 sets? Like we have, more than, 2 elements. So, if we have 1, 2, 3. So, I'm going to say that 1, 2, and 3 is going to be first 5, then 1, then 2, singleton sets first. Then 3, and then we're gonna make their pairs, then we're gonna make them their pairs, like twice. I was just like, 2. So now we're gonna make a pair of them. So first we'll have is gonna be 1 and 2. Then we're gonna have 2 and 3. Then we're gonna have 1 and 3. This could be the all possible, all the possible. Yeah, so this is 2, 2, 3, and 3. Then all the 3. Okay, because every set is a subset of itself. So we'll have these elements, yeah. Okay, so it has 1, 2, 3, 4, 5, 6, 7, 8. So you know it can be, it's like it has 8, it has 4. So you know that basically, you know, it's gonna be, we're gonna, you know, write the P of A like in this way. So the P of A we have is for, you know, element 1, element 2, and, you know, the subset of itself, of course. Okay, so what if, you know, have you show this thing? Oops. This isn't the correct way. It is, but I'm gonna write it again. Okay. So I want to tell you something else in per set and then P of A. Okay, P of A. So we have the number of, you know, number of P of A. So number of elements of P of A. Got it? So the number of, like, let's say if we have maybe 4. So we can write 4 as 2 squared, isn't it? Of course we can write it. Like if we write under root 4 is equals to 2, so we can write that 2 squared equals to 4. So 4 is equals to 2 squared, isn't it? Okay, one more thing. So in this one we have the number of elements P of A. Okay? So, you know, like how many numbers do we have? So it's really simple. So the main topic is that if set A, if you know A is a set with number of set A, number of elements in you know, all the sets, you know, all the elements which we have in set A is equals to M. So what we can say is that if, let's say, if set A, if A is a set, if A is a set of N of A. Okay, so I'm gonna write only this. So N of A we'll have is M. So we can write that N, you know, number of P of A will have we'll have 2, isn't it? 2. How is it so? Is it really 2 or what? Something else? So it's actually going to be, you know, like we just state that N of A is equals to M. So if we have, you know, N, so you know, we have the N of A, so which is going to be M. So M, we forgot to write M. So this is going to be 2M, isn't it? So the part set, you know, basically like it's talking about the number of elements in set A is equals to M. So, and the number of, you know, some P of A is equals to 2M, right? So, as we can say that this M can be, you know, this M can be 2, you know, whatever, but the, you know, this isn't like in a sense. So, whatever, but I would like to say that's it in this video. So, that's all for today, and in the next video, we're going to continue our, you know, today's topic. So in the next video we're going to talk about, and we're going to discuss about the universal set, and then we're going to do some practice questions on all the topics that we discussed in set. Okay, so thanks for watching and have a great day.